Hey, welcome back to the stream. Tonight I plan on telling you more about these PCBs that I was about to print last time, and I'm going to try to iterate on these, and I'm going to probably wind up start thinking about connectors on the motherboard, the keyboard's motherboard that is. So I'll have to take apart pretty much the entire inside of these. Every time I get distracted by the music, I'm like, no, it's soft enough. I won't be distracted, but every time I am. So I'll probably be taking apart the keyboard, taking apart the circuit inside, and removing a couple connectors to the connectors that used to be useful to connect the soft PCBs, which you may recall looked a little like this, like so. And the connector looks like this connector that's right here on the motherboard, here and here. There's one for each side. I'll probably be desoldering these. They look like fairly large contacts, which I would estimate are probably the standard sort of 1/10 of an inch apart, so 2.54 millimeters, which is great. I'll be able to solder regular headers to this. Shouldn't turn out great. And everything, what's great about these keyboards is I was actually told when I bought the first one that they were made by hand, and it really shows, because when you look, like, you know, most of the components are through mount, lots of nice big screws there to play with a screwdriver. So this should be pretty easy to take apart, really, and probably fairly easy to desolder as well. But before we get to that, I want to talk about the PCB, and so you may recall that I spent some time last Monday, was it? Yeah, Monday. I spent some time not reverse engineering, but basically tracing this pattern out on the computer, and I came up with the design in Fusion 360. Now, there's a couple of flaws in that design. We found out before the end of the stream that I forgot to basically project a chamfer from my original frame design onto the PCB surface. So I actually was putting traces in an area where I actually don't have room to put traces in the end. Sorry, I'm moving window here. But never mind. I was still interested in printing the PCB because I wanted to figure out whether the super tight tolerances that I was using would actually work. So the first PCB that I printed turned out not so great. So one of the problems was that I just want to remind people that that basically the idea behind this here, let me just move the focus a little bit in. The idea behind this thing was to print out this like three-dimensional object, like, you know, substrate, if you will, that's full of ridges and stuff, and then take a piece of copper tape. So this is the tape that I was using. It's pretty fat tape. I think it is like 6 centimeters across or something like that, or maybe just 5. Yeah, so 5 centimeters across, which is pretty big. Yeah, and then basically what I do is I lay it on here, and then I press it down with my fingers, and then anywhere where there was a groove in my original design, I actually just run a knife down the groove. Let me just try to focus that in a little more. There we go. I just run a knife down the groove, and that creates these little traces that you can see here. Now this was on the very edge, but maybe this is a better example over here. And you can see that these grooves, they isolate parts of the copper from one another, which is good. It's kind of like a real PCB would work. But in this case, the problem was that I didn't make, I'm not sure that I would say that the grooves aren't deep enough. That's a side effect of the fact that actually the relief, the 3D part that was raised, was not thick enough. You can see here, if I put it on the edge, it's really thin, and there's really not much difference between a groove and a part that's actually supposed to keep the copper on it. That is a poor explanation. I need to find better words for this. So basically there's the raised portion, which is meant to keep copper, to have copper on it. And then there are the grooves, which are really meant to isolate the parts of the copper. So there's not much of a thickness difference, if you will, between the area where there's supposed to be grooves and copper. Now, so the first thing I did is I just took this design, even though it was kind of flawed, because I could tell that in Fusion 360, there were some traces here that were so narrow that the printer, because of the Cura, which is my slicing software, knows that the printer has a 0.4 millimeter nozzle, and these details are like on the very verge of what the printer can do. It's very, very small. It's this is the width of this trace is less than a millimeter, and definitely the trace of the groove in this test was 0.4 millimeters. Now, what I did here is I changed two things. First of all, I didn't bother correcting the PCB design. I knew it wasn't going to be a final version, but I did make it thicker. So I made it thicker and I made the grooves deeper. So you can see a little bit here. If you look on the end, the grooves are a little deeper, and going off memory is either 0.6 or 0.8 millimeters of depth for the groove, whereas this one was 0.4. Now, another thing I did on this one is because I wanted to try to give the traces a little bit more width, I actually took away some width from the grooves, because the printer doesn't need to put plastic where the grooves are. It's able to move the head very precisely, so there can be an absence of plastic which is less than 0.4 millimeters wide, but if it needs to put a strip of plastic that is narrower than 0.4 millimeters with a nozzle this size, it just can't. And again, I could change the nozzle size, but most people print with 0.4 millimeter nozzles, and it's just a pain when you start going smaller than that. I mean, it's great, you get absolute detail on your printer, but I don't want to force people to change the nozzle just for one project. And plus, I mean, let's face it, 0.2 millimeter details are going to be very difficult to make out with a knife and trace across. So what I did was, the second copy of the PCB, I did another thing. So first of all, you can see that there's kind of like this crinkly look, all these little lines this way down the first PCB. And the reason for that was actually just the way that I put the tape on the PCB. It was poorly done. What I did was I actually took the tape off the backing. I'm gonna say it's like a thin cardboard. It's thicker, or a very thick paper. It's kind of in between. And when I took the tape off, what happened is it kind of curled up on itself, and it took this very small radius. And when I flattened it out, it was a bit like just regular aluminum foil. Once the paper has been crumpled up, it can't be perfect again, like Lincoln Park would say. So all these little lines are where the paper had curved up. So what I tried to do for the second one instead was start sticking it down the end and then peel the backing paper away slowly, such that the copper tape was never really rolled up at a very, very tight radius. And that turned out much better. Now, I spent a lot of time actually taking my fingers and pushing down on it to try to trace the grooves out as well as I could, but actually found a much better trick. I took this eraser. This eraser is kind of like this, it's a pencil eraser, I guess, but it's just an eraser. It's not a pencil at all. And then what I did is I rubbed the circuit all the way down, and this really made the details come through. And I could see, before I cut into it, this one's pre-cut up, but I could really see the details. In fact, this is so apparent that you see these diagonal lines here. That's the printer. That's the lines from the top side finish of the printer, which is really quite fine detail. And so I was able to see all the lines, and what I did was I used a knife, this little X-Acto knife, a hobby knife, and I traced down all the grooves, which took some time, and also I poked holes where all the pins and the pads, the pins and the plastic pins and the metal pins from the switches are going to go. I poked those clean through, and then I kind of reamed them with the knife, because the plastic's pretty soft, and even though this knife is not really meant for reaming, it was really quite strong enough. And this turned out to be both, it was a surprise actually. It turned out much better than expected, which is to say that even I'm running down, I don't know if you can see the detail here, but it's pretty crazy, really. I'm gonna crank up the focus even more, but this thing, I mean, the details are just the traces are super thin, and it worked. It really worked, even though here there's 0.3. Oh, what's going on here? It seems like the camera's stuttering or something. Let me just check, is there a problem with the light control, low light boost or something like that? What if I turn that off? No? Okay, there's something going on here. If I restore the focus, is that any better? It is. Okay, so something about the focus. Let me just see if I can. All right, so it's kind of a middle ground, I guess. It's really, it worked. So each of these traces is actually separate, electronically speaking. And the big pads worked super well as well. It turned out great. I did have to kind of mess around a little bit with the corners, because the corners, if you look here, these corners are super tight. So only the very tip of the edge can get in there, of the knife edge can get in there. It's a bit of a pain. The ideal for me would be to have, you know, slightly wider grooves, slightly maybe narrow, deeper grooves, so that it's pretty easy to distract the knife across. Moreover, let's not forget that this PCB design, it had too many traces that it was trying to pack here in this width, and I'm actually losing part of this because of the chamfer in the design. You'll see that in a sec there, but basically this part of this PCB, it's actually narrower in actual fact. So thinking back upon this, what I think I'm going to do is I'm actually going to forego all these thin traces that run all the way down the PCB. I was trying to run them all the way down to the end of the board like these do, you know what I mean? Like run them all the way down, and then all I need to do is just solder them to some header or something like that. I think I'm going to forego that idea. I think what I'm going to do is instead I'm just going to put a regular connector on the keyboard motherboard and then run some longer wires to a couple areas on this PCB. Now, I'm still gonna isolate sections of this PCB, but I think I'm gonna make the sections much bigger, and the only traces I'll really need are to connect a few of the buttons together. I'll bring up the diagram in a few moments that I traced out last time, but you'll see there's only 2 or 3 pads there that were connected together to one trace here on the right hand side of this PCB. So yeah, and there's actually another problem with the PCB as well, which is after I printed it, I realized that actually I'd been modeling this thing backwards all along. In Fusion 360, I should have been looking at it from the other side, basically. I was modeling this from the top, but it turns out that I actually need to model it from the underside, because this PCB, when I traced it from the underside of the keyboard. So I'll correct that as well. It doesn't really matter. It won't take long to, I think, redesign this PCB. Shouldn't take too long to print one either. And there's still another outstanding question here that I'll probably try to tackle. I don't know if it'll be this episode or what, but one of the things, I think I spoke about the elephant's feet last episode, and the fact that if I was to print these very, very small details here face side down on the printer, you kind of lose some detail, because the first layer on the printer has to be squished into the print bed, which means that all these nice tolerances we've got here are kind of lost. On the other hand, if you look at the new design in Fusion 360, I'll bring that up in a moment. Then I've got some parts that are actually difficult to let me bring up Fusion 360 here. They're difficult to print with the printer without support, and so I might actually have to split this in half. Where's my Fusion there? Fusion 360. There we go. It's going to come up in a second. Sorry, using the wrong scene there. But otherwise, turned out really happy. I'm turned out, super happy with this thing. If you look even at if I stick a switch through here, I guess give Fusion a second to come up there. I'll go back to this scene. If I stick a switch through here, the pins come out nice and tidy on the other side. Be pretty simple really to solder to them, I think. So will this work? We'll have to take over again. There we go. You can see the pins nice and all the way through. That would be easy to solder to, which would be nice. So I don't have a ton of spare switches. I think I have like a dozen spares maybe, so I can't really afford to mess up too many of these things, or I'm going to spend a lot of time soldering and desoldering. No, what's going on here? It won't come out. All right, so Fusion 360's come up. Recovery. It's asking me about recovery. I'm gonna open this one because I know my machine rebooted because of Windows update last time, so that's fine. I think the rest is fine. Hello. Okay. So I'm gonna go back to the drawing board and start working on this PCB, and then once I've got a copy of it, a prototype, I'm going to start that print. Oh, by the way, I've started shopping for some replacement bearings on the printer. The noise is really driving me mad, as I'm sure it is for you. And I'm gonna get some dry bearings. I think there's this really popular called a type of bearing among 3D printing enthusiasts from Japan called Igus Drylin. I don't know how to pronounce them. Drylin is like this polymer. It's got this like lubricant embedded inside it, and basically it's completely silent. It sounds great. Or rather, you can't hear it really, so you can't say it sounds great. It just doesn't sound terrible. That's better. That's a step ahead of what I've got now. And yeah, pretty much. I mean, they're a little expensive. They're on the order of like, I don't know, $4 or $5 per Canadian dollars per bearing or something like that, depending on where you get them. So I'll see. I haven't found a source yet, but that'll hopefully make this printer much more silent. So without further ado, let me go back to the main workstation. Here we are. All right. So I'm all set with the latest update. Fusion 360 is really amazing. It moves so fast. There's so much going on. I'm actually going to click on this. And cam, not doing much. 2D drawings, not either. Blah, blah, blah. Crash. Slot renderings. Okay, so there's not that much this time, but almost every week. Generative design. Very cool. Threads and wow, that's very cool. All right, I don't want to get lost into this. I don't want to get sidetracked. So, I'm going to fork this file. I'm not going to keep working on it, but I'm going to get rid of some of the steps or some of the steps. Basically, I'm going to rework this sketch. This sketch has got to go. It's not really great. So I'm going to save as PCB box course, not Karaz, course PCB. Course. Let's call it that. All right. PCB box course. Now, if I remove or suppress this feature, you can see kind of where this was going. Now, as it turns out, this is the way it's going to mount inside the keyboard. Keyboard's kind of like this, blah, blah, blah. And let me bring up paint.net to show you the soft... All right, so this is seen from the underside. So the top side of the keyboard is on the, basically this is looking at it from behind. I was tracing this over from the top in my design, which is incorrect. So I'm gonna bring this to my second monitor here. And then I'm going to, what was this again? I can unsuppress the chamfer. Because that's a bit of a pain, okay. And then box primitive, unsuppressed, what is this? Oh, that was cutting into stuff. I'm gonna delete this because there we go. This is the extrusion, this is the intersection to print the last thing. Okay, so if I look at it from the underside like this, bottom, there we go. Bottom. So now this is correctly reversed. All right, this is good. So you know what? I think I'm going to just start over here. with this design. What did I do here for this extrusion? I selected all these profiles and then I merely just extruded down to cut. But so my main question is here, what's going on with this? See, this plane is in this sketch. It's extruding one direction. Oops, I didn't want to edit the sketch. Sorry about that. I wanted to, yeah, that's from this side. Okay. I wanted to edit this. Which is 1 millimeter one direction, 0.8 in the other. So 0.8 is the thickness of the grooves. Are those channels cut into the bottom going to be, hey, Dead Pixel Design, are those channels cut into the bottom going to be traces? Yes, they are. Sorry if you I guess you just joined the chat there, but I can show you quickly. It looks a little like this. Yeah, okay, let me take over. It looks a little like this. This is one of the earlier prototypes that I made. These are 0.3 millimeter wide grooves, and I just ran a knife down them, and it worked quite well. On the other hand, I'm just out of room for traces. So I was saying I'm gonna design this to be a little coarser, probably bigger than a bit like these big pads here on the edge. If the camera will focus for a second there. No, okay, I'll take control. There we go. Like this. What I'll do is I'll isolate these bigger sections and I'll run wires to them from the keyboard's motherboard. There we go. Cool. Yeah, hopefully we could get a better version of that going a bit later tonight. Actually, maybe start soldering some switches. We'll see. All right, so I'm gonna undo this part here. I'm gonna get rid of this sketch. Get rid of all this. Get rid of the PCB. And then I'm gonna create a new sketch, but here in the time frame. So I happen to know that my original sketch for the first part is in the origin plane, so I'm going to use the same plane again. But this time I'm not going to make the same mistake. I am going to turn it upside down and rotate it this way. Okay, wait, I just want to make sure I'm not screwing this up again. That PCB that I have here is actually the PCB that was on the right side of the keyboard. So it is keys F7, I believe, all the way to, sorry, F9, all the way to remap and program. Which means that when I design this PCB, this part is meant to be up top, and then this is going to be on the bottom. And so this thing on the left is actually, okay, this is correct. This is correct. It's lined up with the program key. So now all I have to do is replicate the design, or the logic, I guess, of the original PCB, and figure out how I'm going to route my wires. All right. Start by projecting some stuff, just like we did last time. I projected, last time though the face was upside down, it was a bit easier. I project this face here. If I hide the body, is that enough? So if I'm not relying on the chamfer, which I shouldn't, then actually that is perfect. This is full surface that I can use. Okay. Awesome. So going back to this thing that I traced last time that looked a little like this, I'm going to use this as a guide to isolate these areas. So what I'm going to do is, instead of routing, I'm going to take these two pins here, I'm going to isolate those together, create a big pad here, And then forget about this little trace that goes all the way to the edge. For this guy, I'm just going to create a big pad. This guy, just create a big pad. So the only pads that I read, or only, I guess, pins on the switches that I really need to share are this light blue in here, light blue in there, and light blue in here, which should be pretty easy to route across the top. I've got these green ones here, which will be pretty close, so another contiguous area, and then these purple ones here. Everything else, so this yellow one here, the blue one there, the purple one here, I'm just going to make these big, you know, pads, huge pads around these the pins that come out of the switches. And what I'll do is I'll route these wires from the keyboard's motherboard to these areas. I was hoping for a bit of a slicker design in the start, but it's just too many signals to route by hand all the way to the edge there. So I think this will be a nice compromise there. So here it goes, really. Start by just drawing sort of freehand, a bit like last time. Cut away here some areas like this, so this can be one big pad, and then this is already one big nice pad here. Let's divide that up like this maybe. So I've got this signal here, this signal there. You know what, maybe let me try to see if I can't do this with both at the same time there, so you guys can kind of see what's going on. Let me drag this over like this, and then like that. All right, so I've got, this is the green pad, it's over here, this is the red one, the blue one is going to be over here, and I can actually just cut that right there. I'm really just drawing this freehand there. I'll be able to adjust the details afterwards. Then the next one was the yellow pad, so that's the left side of this switch. I can also isolate this one. And then I wonder if I can actually, I can, so I'm not dealing a lot with constraints right now, so I can just forget about the sketch palette for a second and get more screen real estate. So this is 1, 2, 3, 4. This is the, sorry, 1, 2, 3, 4, 5, and then this is the cyan switch. So I need to, let me just for fun there, do this, and then that is 1, 2, 3, 4, 5, 6 pads over. So 1, 2, 3, 4, 5, 6 pads over would be this one, like that. 1, 2, 3, 4, 5, 6. Is that correct? That is the right side of the fourth flash switch. That's correct. Run that like this, like that. I don't want to. Oops, like this. And then keep going over to the last pad on the board. Like this. Oops, sorry, that was a misclick. Like that. So these are nice big regions there that'll be to cut grooves into later on. This gives me more confidence. Yeah, and like this and like this. Move this up a little bit. There we go. And then the purple pad. Okay, let me work this out first. So I don't need to route this purple trace. I'm just going to isolate this pad later on. I'm going to worry about the red one for now, which is this guy here. And just cut this, and now this guy's on his own. So I should say that these big round pegs here, they are the places where the plastic is going to sit through. And every little hole here on this horizontal line, these are the pins. The electrical pins on the switches. So this is the pin for the first switch, pin pair for the first switch, second switch here, third switch, fourth switch, and so on. Actually, the fourth switch, fifth, and so on. All right, so hopefully that gives you an idea. And then this is this red signal over here. So these two pins here should be routed together, which they currently are, but I need to isolate them from I don't even know why I bother aligning these things. It won't be very useful. I need to isolate them from this pin, which is the purple pin. So there we go. So this part here is these 3 green pins here. They touch together. So there's this connection here, which is the left side of the switch, and this is the right side. Sorry, the left. Yeah, sorry. Yeah, this is the left side of the next switch over. All right, so this will be a pad for the purple one. I could make this bigger, because why not? Give me more leeway. I can make this one bigger as well. Okay, I'll revise that afterwards. So this is purple down. This is blue, or sorry, like the teal one, cyan, I guess. This blue guy is going to be over here. For now, I'm going to worry about the yellow one, which is this guy. Nice big yellow pad. This, and you know what? Like this. It's going to be the purple. And that's almost it, really. Let me double check this just to make sure everything's kosher. Okay, so cyan goes all the way over here to the right side of that 4th switch. It goes to the right side of the 3rd switch. Yeah, from opposite sides there. Then purple is left side of that. Skip 1, tack. This is yellow. Cyan again, green. Skip 1, which is purple, green, and then red. Yes, red. Yes, cyan, yellow, and then the red pads. Wait. This is wrong. No, this is correct. Sorry, this is blue. Yeah, this is the blue pad. This blue pad here. And then red. And then green. All right, perfect. So let's see if I can't make this some of these smaller pads a little bit bigger here. This is good. This is good. What about this guy? I could certainly make this guy a little bit bigger. So I'm going to get rid of this line here. Just draw it again, freehand. I don't know why. I felt like a Tetris block shape worked for me. And obviously I could tidy this up. I'm gonna make this, and this. I make them collinear. Oh, which it won't let me do. Oh wait, I don't want to have this. Sorry, will it let me? Yeah, collinear. Oh, I see. I've got to do 2 at once. I see. This one and this one, collinear. This one and this one, collinear. And then this pair. Almost feels like it'd be better to draw on a grid, but alright. It's collinear. Collinear again. And then this and this could be collinear. So that what means is that if I move this, now it's fine. If I move this, then all these move together. If I move this, then all is well. And I've got, all right, so I'm gonna move this back to the other monitor, or rather make this one full screen. And then I suppose I'm gonna start offsetting all of these. Let me save. Alright, groove width. And I'm actually going to wait. I'm going to make the groove width a little bigger here. Enjoy some of this newfound freedom. I think 0.5 is about right. Okay, so groove width. Okay, chain selection, groove width, like this. I'll reposition things afterwards. Oops, that was a bit hasty. Groove width, offset that. Groove width. That's interesting how it won't. Oh, there we go. Sometimes it's not sure about the chaining of the selections and stuff. Groove width. We start offsetting. All right. Width. Oops. All right, this is starting to look like something. Oh, what's going on here? Okay, for some reason that was dialed in wrong. And so just let me just make sure here, if I change this parameter, groove width, I make it say 1, everything change? Oh Lord, what happened there? So Death Pixel Design is asking, is groove width a predefined size you're assigning or just a label so you know what they're called in the list? It is a predefined size, so it's what's called a parameter. So Fusion 360 supports this I guess this way of working called parametric design. So you can define all these dimensions, or in my case they're all dimensions, but it could be, well, in this case actually it's a number, so number of keys in my keyboard. So in one of these steps in this design here, I actually tell it, well, repeat say the whole pattern or something 9 times over, and so on. In this case, I've got a little thing called groove W, stands for groove width. When the names get super long, it's really cumbersome to type all these formulas. It's a value that I just set currently. I had it set to 0.5 millimeters earlier, and the idea is when you change this, it's supposed to change in the design. But what's weird, what's really strange, actually, let me just give you a better example. So groove width didn't work there a minute ago, but if I change, for example, the I don't know, say the number of keys, then, and I've got 5, and I change this to 5, then you can see how actually this is not quite right. Something's going on here. Number of keys 1. There's something about something about my equations that's not quite right. Wow. All right, it's always when you're live that something goes wrong. All right, let's go with a smaller one. So let's go with, say, box depth. And if I change this to, say, 15 millimeters, then the box goes deeper. That's the idea. That's how this is supposed to work. Now, I must have gotten something wrong with my formula somewhere with the number of keys. I may be using it somewhere where I shouldn't be. That's a really interesting one. I'll have to circle back to this one and figure out what's going on here. But the idea, yes, if you have these parameters and you can just change them and everything follows. Now, normally the groove width would have followed as well, but for some reason when I was punching these into the sketch, was this the right side? No, it's the other way around. Sorry, bottom, like this. Oops. Yes. For some reason, see, normally what happens is when you punch in a dimension and it actually is symbolic and it's driven by a symbol, there's this little FX here that shows up, right? And if it's just a hard-coded value, like for example this one didn't go through for some reason, it just says 0.5. For some reason, I think I must have mistyped something. I'm not sure exactly what was going on there. But all of these got punched in clearly as 0.5, which was the value of groove width at the time when I hit it, when I hit enter. So really strange here. But I'll give you another example. Once I'm done correcting these so that they're actually function driven. Shouldn't be too long there. Oh, this is a new one. Okay, kind of a hang there, a little freeze. Okay. So all of them look like they're parametric now. If I change this value, in theory, there we go. In theory, if I change the value, make it 2, there we go, all the values change. So this is awesome. Now it works. This is the way it's supposed to work. There's something wrong about the number of keys example that I chose earlier there. I'm not sure what's going on there. Sorry about that, but I'll figure that out a little bit later. For now, all the dimensions are okay, which is good enough for the current case, I guess. So let's stop this sketch and then go back to making these grooves, or isolations, I guess. So let us extrude. Then let me select all the profiles to extrude. I'm going to use these to cut into the plastic. All right, show the body again. Now all of these became grooves. And you can see they're, this is nice. They're nice and thick. Should be pretty easy to drag the knife through this. All right, I like this already. All right, so this is the top side. And yeah, this should actually match the way the PCB was laid out on the keyboard. So what I was saying earlier is if I print this on the bottom side, it's a bit of a pain because, oh, I got a question there. Dead Pixel Design, how did it know they would be a loss, not just add material? Great question, great question. All right, so Fusion 360's got some smarts. It's really pretty smart piece of software. It's free, by the way, if you're a hobbyist or not commercial. If you make, I think if you make less than $100,000 a year as a business, you can also use it for free. And even if you have to pay for the license, it's really not that expensive. It's a monthly subscription and it's quite affordable. But I have a non-commercial license here that's renewed every year. So the way this works is, sorry, I did go a bit fast there. So you see how here it's in red? So the red is kind of their convention to say, oh, it's going to cut into the material. But why is it deciding to cut instead of adding? So what it does is it actually looks at what you're trying to do. So I'm going to give you another example here. If I was to say, let me make another sketch for fun. Let me save this. And then let me make a sketch. And then say draw a rectangle and then a circle in the middle like that or whatever. And then I stop the sketch, and then I go back to the extrude command, which is what I use to cut these grooves. And I say, hey, I want to select the profile that I want to extrude. That's the first step to do. So I'm going to click on, I don't know, this gizmo here. And then by default, when I drag it, it goes and it adds material. So the operation by default in this case is new body, which means it's going to create a new body in this list over here on the left. Now I've only got one body so far before this operation is complete. It's this whole assembly here. I'm pointing with my hand and you can't really see what I'm doing. But this assembly here on the left is the assembly called, sorry, I shouldn't use the word assembly. It's a body called PCB. Assembly means something else in Fusion parlance. But let's say that I go in and I click OK, right? So then the sketch disappears, like it's okay, well, you're done with the sketch. Okay. But then I'm like, wait a minute, I actually wanted to do, or rather, sorry, let me go and re-edit this operation and then add this body to the feature. Okay, so now it's extruding both these profiles, the quarter around here and the other part of the square. So it's got this block and it's got a new body. Now, actually, what I wanted to do was I kind of want to remove part of this body. So I'm going to go and fire up extrude again. I'm going to bring up the sketch that it just hid for me. And I'm going to select, I have to hide the body actually to be able to select. I'll select this section here. And by default, it's like, oh, I want to add the body again. Okay, that's fine. But the reason for that is because it sees that when it extrudes this in space, there's nothing to intersect with. Now let's see what happens right here if I re-enable this body here, body 40. Aha! Now all of a sudden this turns to red, like it's going to cut away. Notice how the operation here on the right goes to cut. If instead I start extruding it out to the bottom, then it turns to join. And now what's cool about that is that it knows that because this is contiguous to the original body, it shouldn't be creating a completely new body. And if I actually finish this, then I've only got this one body here, body 40, which is this whole piece here. I could, however, have gone back to this piece and said, instead of new body join cut, you can do intersect, which is another case. Hey, Jeff Purse, welcome. Welcome to the stream. You can do something called new body, which in case is actually forcing it to create a separate body in this hierarchy here. So if I hit OK, then you can see that I've got two separate bodies here, this top body and this bottom body. So you basically have control over the operation. It makes a smart guess about what you're trying to do. In my case, the guess about removing material was correct. I was trying to there was an intersection there. I was like, you're probably trying to remove something. But you can override that and you can tell it to add if you need to. Yeah, so I hope that kind of clears that out. That up. I've got here, I'm just going to get rid of these 3 steps. I'm going to show you quickly here if I go back to the future and and I unsuppress this feature here is actually a, oh, it's a cut, sorry. For a time, it was actually an intersection that I had there. Yeah, for a time, oh, maybe it was the other one that I got rid of earlier in this episode. Anyways, I had an operation that was an intersection here, which basically means take only what is common to both bodies. Yeah, there you go. I'm going to suppress this again. Look at the full thing. I might actually try to print this as a whole. It'd be less pain. Another way to do this would be to actually slice the body here. I could slice this and then print it as 2 parts and possibly glue them together. But because these grooves now are 0.5 millimeters wide, I'm feeling confident that the elephant's feet won't be such a problem on the printer. You know what? I'm going to widen the grooves even more and make them 0.6 millimeters. Nice thick grooves, and I'm going to try to print this with the PCB face down. I'm just going to go back to the sketch and correct a little bit there because these grooves are getting a little close to the pins of the switches. Oops, that's wrong. Let me move this part instead. Oh, that's weird. Ooh, what happened there? So sometimes the constraint solver there goes a little bit berserk and it won't me move exactly what I want. Especially with these offset curves, it's a little weird. I was having this problem last time as well. Yeah, sometimes the constraint solver doesn't deal super well with all these extra constraints here. See, these two, there's no distance constraint between this line and this line, yet when I move one, it moves the other. So it must be thinking something about... Maybe it's the offset actually that's screwing me here. It has to preserve some relationship that I'm not sure. Okay, maybe it's this guy here. This offset has to remain the same. No, that makes no sense. Nope, not sure why it's doing this. All right. I'm just going to try to move this one over a little bit, and if it doesn't work, I'm going to move on with my life. All right, good enough. All right. This is really starting to take shape here. So let me try to export this. Let me just see how much time it's telling me that it's going to take to print this whole thing. If it's too long to print on stream, I might either just do a part of it, or I might do the... Hey, JF Purse asks, I see I missed quite a bit. Are you going with wires in the end? Yes, I will go with wires, but I'm going kind of with a halfway solution. So one of the solutions that I thought of much earlier was if the PCB thing didn't work out at all, I could actually just point-to-point wire the switches directly to the motherboard on the keyboard. That would have kind of, I don't know, it rubbed me the wrong way. So as you saw, I tried to route all these thin traces all the way to the end. It didn't quite work out. It didn't have enough space. You know, probably with a smaller nozzle and a lot of patience with the knife, I could have gotten it to work. But I kind of have this goal that I want this to be easier to replicate. I don't know if people are going to try to do this over again, but I do plan on publishing the STL files at the very end, which hopefully means you basically just print this out, have a little bit of copper tape, you know, spend, I don't know, at most half an hour cutting up the tape a little bit, and then a little soldering job, and bam, you've got, as long as you've got the switches, of course, you've got an upgraded keyboard. So yeah, I think most of the work is going into designing this part here, and obviously the other one that's on the other side of the keyboard is not symmetrical. The PCB is not the same, but hopefully if this principle works out, then the other side shouldn't be too difficult to design either. Everything is going to be the same except for the PCB. So yes, I will be going with wires to these big pads here. So I use this this drawing here to kind of isolate the pins from one another. And now it's the moment of truth. So let me save this again. Let me see if I export this as STL. Let me start firing up Kira. If I export this as STL, Let me turn on the printer as well. Cool. What's going on here? How did this get unpinned? I'm going to start Octoprint, and I'm going to bring in the PCB. Okay. I'm liking these odds. I'm liking these odds. So I think for the final product, I'm going to print this with like super high detail at 0.1 layer height. Maybe even 0.5, though I don't think that would make a difference for this. Perhaps for the keycaps. Here, let's see what it tells me for a 0.2 layer height. 0.2 millimeter layer height. I'm guessing it's going to be close to like an hour. Just eyeballing it there. An hour 04, okay. If I go to 0.3 millimeters, I'm going to lose some detail. I think it'd still be a valid prototype. 45 minutes. Okay, that's still a bit long. Actually, and there's another problem here, which is that the layer height, if you look at the depth of this groove, it's 0.8 millimeters, which you may have noticed is not a multiple of 0.3. So I think I better stick with the 0.2, because 0.3 is really quite coarse. I'm going to stick with the 0.2. But what I am going to do, though, is instead of printing the whole thing, I'm going to print half of it, or maybe just even 3 keys. So let me edit this feature. Like this, like that. Let's see how that goes. I will, of course, print the full thing off stream there. It's just I don't want to spend hours, you know, like waiting for the print to go. The printer is like reasonably speedy. I think I've got it set to 60 millimeters a second here. Which is a decent speed, but it's still gonna take some time. So yeah, sorry. All right. Now it's got me wondering, is it more interesting to print this side? This guy's got more traces. Does it really? It matters. Okay, yeah, I'm gonna print the other side. Like this. Patterns look more interesting. Okay, and then all right. Save this. Get rid of this. Re-import it. It should be a much more modest time. $22 minutes. That makes sense to me. I'll buy into that. So I always kind of move these up to the corner because my print bed is not fully flat. Actually, the print bed on my printer is unfortunately, oh, still got the camera going on there. Is unfortunately, I think it was don't want to say damaged in the shipping, but it was never fully flat when I got it. So I actually ordered a glass plate quite some time from China, quite some time ago, but it never arrived. I assume it is shattered in a million pieces somewhere on a boat in the middle of the ocean, perhaps. I might order another one, or I might try to chase them up and get them to send me another one. Hopefully the plate of glass would make things a little flatter. But for now, this kind of upper quadrant of my print bed is pretty flat. And I also have a 3D, like a print level sensor, an auto level sensor that I plan on retrofitting later on to my printer, which will allow it to kind of probe the bed and figure out, do some math and deform, basically adjust, compensate for the bed warp, which you want as little bed warp as you can to begin with, but them's the breaks, them's the breaks. All right, so let us prepare this and see if Octoprint is ready to talk to the printer. It is. Let me preheat the printer. All right. Very interesting. It's looking good. Looking good. Damn pirates. Yes, damn pirates. Get stealing my pieces of glass. Indeed. Yes, but they'll probably, I'm out for now. Thanks for answering all the questions. I'll log back in a bit and hopefully catch you some more. Well, thanks for showing up. Thanks for joining and asking the questions. Really pertinent questions. All right, so I'm going to save this to file. And then I'm going to upload it to the printer. So this is a Dropbox directory, and for some reason it never updates the date properly. This drives me mad. A PCB.G code. Yeah, this is the one. It's weird. So the printer's up to the target temperature already. Print. So it says 21 minutes. It's adjusting. You see the print head temperature. Hear it start moving in a minute. I'm then going to clean out my desk, bring up my soldering station, and start taking apart the keyboard. Any minute now. There we go. All right. All right. So there goes the printer. Just gonna make sure everything's all right there. Looks good. Oh, I see my print bed's a little, the tape's a little damaged. I should bring the camera closer because it's a little interesting what this looks like. You can kind of see what it's doing there. So this first layer is kind of the underside of the PCB, if you will. Sorry for those cables that are in the way. He's kind of filling up those holes. I think I'm asking a lot of it though. Yeah, I don't think that's gonna work out. Yeah, I think it's filling everything up. So part of the problem here is the fact that I've got the first layer set up so that it actually is supposed to be 0.3 millimeters thick, and I'm really getting it to smoosh that first layer into the print bed. We'll see. I'll let it go for a bit, see how that turns out. So I'm gonna move this crap from the desk here. I've got a bunch of like test parts and everything from the keyboard from earlier prints. Got all these switches here that are still on this test piece. Oops! Sorry about that. My bad for sending you tumbling. Alright. Let me readjust this foot. Or the tripod, I should say. Alright, let me move this to... I've actually got a parts tray. Ooh. It's in use. Take a different container here. There we go. Put all of this in here. All of these experimental parts. All right. Now, all right, it's time to take the beast apart. I'm going to need to take apart 1, 2, 3. So this connector here is glued, unfortunately, which means I can't just take this motherboard out. I need to take the whole caboodle out, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 screws, that looks like. But they all look the same, which pleases me. Of course, the screwdriver I was looking for was the last one at the bottom of the bin. So, let us begin. And part of what has me worried here is I'm not sure exactly how flexible this is. Oh, wait. Yeah, no, sorry. Okay, yeah, this is not meant to come apart. Exactly. Alright. I'm not going to pull on this too much. Break anything. Okay, so this screw is a little longer, it's a little different. I wonder if it's symmetrical with this one. Nope. Okay, so far so good. All right. Oh yeah, got the main screw. Okay. Now these are all the same. Oh, this is great. It just lifts off. I don't want to break anything. I don't want to break anything. Now, like it should be said that that people do make complete replacement motherboards for these keyboards, and they're actually much smarter. There's this key, you know, the firmware in this is super old, and there's a couple annoying bugs with it. Keys get stuck sometimes, particularly the caps lock and shift and alt keys. I've gotten used to it over the years. I don't even notice it anymore. But people do take this board out and replace it with a board that's based on the Teensy, I believe, which has, you know, native USB connectivity, and it runs this really fancy keyboard firmware. I think it's a 3-letter acronym. Somebody out there for sure knows what it is. I wasn't familiar with it until very recently. Q something. So if I fail at this, if I miserably damage this board, which hopefully I won't, but if I do, there's always that option as well. And I could always, you know, because that upgrade board is made to take these original PCBs, I could perform the same modification on the upgrade board and have my Cherry ML switches anyway. So got a couple layers of security here. Could be doing this on an anti-static mat. Not overly worried though. At this point, oh, an extra loose part here. I'm just gonna take these screws, move them over to my bin of loose keyboard parts to make sure I don't lose anything. I'm just gonna lift this out like that. Wow, this keyboard looks naked. You know, I could really clean this thing now that it's apart. All right. Just get rid of some crap here. Print's coming along nicely. I'll try to flip this over without damaging anything. Okay, these are the extra screws that were in the top of the keyboard wells right here. And ooh, aha. So let me show you what this looks like here. All right. So, hello, will you focus, please? Big fan of the C920, but the autofocus, yeah. It's not the best. There we go. So looking at this here, this is both good and bad news. These pins are a little more tightly clustered than I'd expected. I do believe they are the expected 1/10 of an inch apart. That's what it looks like. Let me measure that. Actually, you know what? I have header pins here that are exactly 1/10 of an inch apart. Quantum Cross. Oh, am I messing with an expensive board? Yes. But you know, to me, I think, like I was saying, you know, you know, I could always get a replacement board for this thing. Oh, I hit the table again. Sorry about that. I could always get a replacement board for this thing. And that's it. I mean, at the end of the day, these keyboards are very difficult for me to use now because of the function keys. So I got to do this, right? Otherwise, I'm getting new keyboards. So it's sort of a do or die thing. Well, not do or die. That was a bit dramatic. All right, so this looks good. It is exactly the standard spacing. So that means I could put 2 of these rows of headers here, either female or male or whatever, and then connectize that up But it does mean that desoldering this connector is going to be a bit of a job. It also means that an alternative that I have here, instead of desoldering that connector, would be to look at where all these traces wind up and run wiring directly to these to these points here. But the part of me feels like that would be even less tidy than what I'm about to do with that, you know, basically that I reneged on my initial idea of having a full PCB with traces that ran all the way to the edge and the top here. So I'm going to try to desolder these connectors. They're quite cleanly soldered though. Now see, if this was a one-way job, I'd just use my heat gun. In this case, I don't have a hot air rework station, but I do have some pretty fat nozzles. I think that's what I'm going to do. Ah, man, I wish I could take this apart though. Everything is soldered together. That's a bit of a pain. Alright. No pain, no gain. Alright, I'm going to pull out the soldering station here, move this keyboard out of the way. Plug this in. Alright. I'm going to start to run out of space soon because of the 3D printer. I'm going to find a new home for it soon. Put this in. There we go. All right. Got fairly little space going on here. Take out some distilled water, get my sponge wet. Just a little. So this is my tip of choice normally. I work with this super fine tip. I am going to switch for this job. I think the one I'm going to use is called the ETK. Oh no, sorry, I'm not going to use the ETK. That's the knife tip. No, I'm going to use this one. This fat tip right here. All right, I'm going to take apart the soldering iron. Take out the tip. Replace it with this one. Now normally I forget to do this until the iron is hot, but this time I thought for the benefit of the viewership, I'm going to go and do it properly. All right. This is really cramped here. I've really got to find a better place for the printer. All right. Is this going to move? Yes. Yes, it is. So I've got a vise, I've got a universal vise that looks like this, that I frequently use. It's got a ball joint and everything to hold PCBs, but this one's got so many dangling pieces off it that I'm not going to do that. I am going to use this instead, which I guess you can call like a third hand. I mean, in this case, it's like the third, fourth, fifth, you know, and so on. There's seven hands on this thing. And I'm going to try to just hold the board in place gently while I molest it. Time to invest in a vacuum desolder tool. Yes, indeed. I've had my eyes on those. That would be awesome. I'm a fan of the pump myself, but yes, indeed, I agree. That might be one of the next purchases. So I must admit, though, I solder a lot more than I desolder, but for that, you know, that one odd job. I know Hakko have this really nice model. And there's a couple imitations out there. Unfortunately, there's some of the imitations are actually quite well reviewed, but most of them actually run on 240 volts, which so I'd need like a transformer or something to boost the voltage up here. All right, still moves a little bit, but this should be workable. All right. All right. Crank the heat up a little more than I do normally because you have the Hakko and I rarely use it, but when I do, it finishes the job in seconds. Yes, absolutely. You're convincing me there. Oh, sorry about that. The tripod's falling apart again. I'll correct that for you. There we go. Man, I don't like having this keyboard well right in the middle of the path of the soldering iron. I feel like I'm gonna experience a fail on air here. All right, just tinning the iron. Get the pump and some wick ready just in case for now, but my first goal is actually going to be to heat up all the joints and then just pull off the connector. This is a pretty fat board though. There's a ton of thermal mass here. I can see the traces are really fat, so I'm not too worried about damaging anything else. And there looks like there's nothing on the board that's even remotely close that would take damage. Plus all the chips are in sockets, so fingers crossed. Right. I suppose another option here actually would be to use maybe like a pencil torch. Alright, I'm going to... Let me see if I can't get a third hand in here. Try to stabilize this even further. There we go. There we go. All right, that's marginally better. Okay. So I'm going to start by adding some solder to all these connections, all these pins here. Be generous. Be quite generous. It doesn't really matter if I just almost like drag solder here, because my only goal is to reflow these connections, and then I'm gonna try to heat them all up at the same time, more or less at the same time, such that I can pull off the connector. Oh, almost. I've already almost got it. Almost. I can feel it coming apart. Come on. Come on. Almost. Ugh. Okay, that was unexpected. Come on. It's coming out slowly, but it's coming out. Come on. One of these is really stubborn, actually. Uh-oh. Losing grip here. It's really going slowly, but it's coming. Come on, boy. Alright, I'm gonna add a bit more. It's like 3/4 of the way there. But not quite. You can do it. Thank you. Thank you for the encouragement. Alright. Reflow this again. And then all the extra solder I can just remove afterwards. This is such a pain. I've almost got it. Almost got it. Almost got it. Come on, boy. I can't see with pins being a... Okay. Uh-oh. Alright. So I've got most of it out. One of the pins decided to stay in there. It's just really the stubborn one. Yeah, clean the tip. Board looks a little dirty. There's a little but no, it looks still in shape. All right, so I'm going to clean that up afterwards. But before I do that, try to make these grab a much more solid grip on this board if I can. All right. Yeah, got one pin here. It's quite stubborn. And it isn't whole. Third down from the second row. There we go. Is there anything else? There's a bit of junk here. I'm trying to get that out. All right. Man, I really wish I could turn this board vertically. Because then I could use the pump much easier. Could I do that somehow? I could tilt it up a little bit. Like this, maybe. Hooray, yes, thank you for the encouragement. All right. Yeah, there's a bit of crap left on this side of the board. The connector really came apart quite poorly. I can see that it was, it got, well, I don't know if you'll be able to see this, but one down, one to go. Yes, well, although this one still needs to be cleaned up quite a bit. The board, there's still a bit of crap there. But what I'll do is I will clean it up from this side first. Though, actually, maybe I can clean it up from, yeah, the best would be from that side, but. Ooh, the print job finished. Ooh, goodies. Very nice. All right, let's get back to that in a second. Ah, man. Have to find some way to support this. This is an unanticipated pain. All right. Can I even get in there? Not sure. All right, well, I'm gonna try to heat this up and pump it from the same side. Sorry for the hand there, I'm just gonna do 1 or 2. Okay, I got 1 down. Yeah, it's crap in these holes, it's blocking some of the holes, so. Oh, I managed to pull some of that crap through, actually. Just using the immense power of the cheap vacuum. Yes. Holy cripes. There's a bug on my desk. Oh. I've got a dirty iron here. This would be 10 times easier if I could reach through from the other side. Oh, the camera's not the... Alright, it's alright. There we go. Oh, that's great. My pump decided to dump everything on this board. Ah, what's this? Garbage. All right. Okay, well, this is looking all right from the other side, so it's, I guess, just a matter of being patient. About half done. It's not the best tip for this either. All right. I think I just sent one of these these little bits of solder right into the keyboard. All right, well. Such is life. Oh, that was a bit quick, or slow rather. All right. Getting there. This is really one of the longest solder pump jobs I've done in my life. It is the longest job I've done in my life. Normally you just get in there and from the other side and it takes 2 seconds, but it wasn't meant to be. Okay, let me try to clean up this board a little bit. It's looking a little sad. Looks like the only tip I have on my iron. I hate it. It's soldering time to buy some tips. Yes, I don't know if you saw this one earlier there, but this is really the best one I have. It's like a super fine one, and it's like, you know, compared to these holes there, it's very tiny. I use it like 9 times out of 10. But the one I'm using now is great for thermal mass transfer, or rather, it has a lot of thermal mass. It has a lot of contact as well, and it's good for thermal transfer. Let me try to clean this up really quickly. This is just alcohol. There's a bit of a... Yeah, this is definitely not the cleanest job ever. Definitely not. There's a bit of a burn mark here. Is that a burn mark or is that just flux? It's hard to say. Board seems intact though. And on the other side, it looks good. Let me see if I can actually poke some headers through all these holes. Wait, these are my female headers. I think I have a couple males. There we go. Okay. There we go. So can I fit header through all these holes? Eesh. They're still a little too grody. They're close though. Oh, actually, wait, what's going on here? Oh, the holes are a little small for these header pins. Oh, that I had not considered. Yeah, these pins are actually quite small. Wow. Okay, let me take a drink of water here. I'm wondering if that's just... No, okay. No, it does fit. Okay, I just need the holes to be really clean. Which they are not, clearly. Okay. And wick is not, I hate working with wick, and it's also not going to get the very last of this crap out of here. What I really need to do is find a way to get this board to be vertical without damaging anything. So I'm not worried about this bit because this is flexible. I'm worried about this bit. How solid, how sturdy is this really? I don't want to break it. I'm basically trying to weigh the risk of making this vertical and trying to get it to rest on something. So I really don't want to break this board. If I break this key well, no, that's just that's something else. I suppose I could try and go at it with the pump a couple more times. I know there are smaller pumps out there as well. I only have this huge one. I need a lot more travels yet. Okay. Okay. I've got an idea. It's a little harebrained, but I've got an idea to make this keyboard vertical. All right. So this connector is garbage. Let me get rid of that. No going back now. All right, I'm gonna use my third hand to hold the key wells in place. Like this. Wow, exactly like that. You see, you can see on the camera, right? Right? All right. So I'm gonna use basically, I'll show you in a sec there. But basically, oh boy. Oh boy. Oh boy. Basically, let me move the camera out there so you can see. I basically got it set up like that. So 4 arms holding a different part of the keyboard. Why won't this camera focus? Is it still on manual focus or what? There we go. So now I'm going to try to raise this slowly and slowly until I can make this board close enough to vertical that I can use the pump on this backside like this, because right now I can't really reach underneath the board. I just need to make it a little more inclined. All right, so slowly. And very slowly. Man. Okay, let me move the camera back a little bit, see if you can see a little more of what's going on there. I don't know about this. Okay, this isn't too bad actually. So by the way, you mentioned hating your soldering iron tip. I must admit, geometry is a big factor, but there's another factor as well, which is you know, making sure, I guess, that the tip is really clean. Well-maintained tip, man, makes a huge difference. I've actually had these tips. I've never replaced them since I've had this station for maybe 10 years. But before I had this station, I had plenty of other irons, and I kind of wasted a bunch of tips, not knowing really how to take care of them, which I guess maybe is a topic for another day there. But yeah, it's making, as soon as it's like pitted or rusted at the very end, it's not going to work so well anymore. Now these are still in pretty good shape, so I am going to try to use them right away to, okay, I can almost get in here. Almost. All right. You know what? I'm going to try to see if I can't like line it up ahead of time and then just whew. Yeah, this is painful. All right, like that maybe. Okay, this is not gonna work. Man, what do I do? So I could cut apart the glue that's on the back of this and just disconnect these motherboard, these daughter boards, I guess they're called. I could do that. I'm assuming the glue's got to be there for a reason, though. Maybe they had reliability problems if they let it be disconnected. Man. All right, let me just manipulate this for a bit more, just to. I'll check that. Also, when desoldering, is desoldering braid useful, or when is desoldering braid useful? I haven't had that much success with it. I've always worked best with the pump. Yes, I'm also a pump man. I find that people prefer one or the other. I do have braid for. I've used it for like it's more practical for some SMD scenarios when you're soldering like these tiny components on top of a board. If you have excess solder, especially if you're drag soldering, if you're soldering like a million pins at once, you can get rid of the excess with this. Pump does, it's a bit trickier to get that result with it. And I suppose when you're really trying to soak up like a lot of solder, this works quite well as well. But I'm not sure actually if I could get this. I don't think I could get the wick to work here in this hole. You know what? Let's give it a try just for fun. Let's give it a try for fun. I'm gonna wear a glove for this because I hate getting burnt and I do it pretty often when I use wick. So first thing with the wick is you just gotta, could you actually drill the holes clean, or is that too risky breaking the board? Yeah, it's risky because what happens is these actually have a coating on the inside of the hole. I wish I could show that, but it's way too small. There's a coating on the inside of the hole that makes contact with the trace on the board. And so if you damage that coating, that's bad news for connectivity. Really trying to get the solder out is the best way. But it does, if I could get in there with the pump, it would come super clean. Like, it's amazing how clean it comes. Yeah, but we'll see what we can do with the wick. Just for fun. So I don't need access to the backside with the wick. But here, let's see if this works at all. Yeah, see, I managed to I managed to move the solder around is what I did. For through holes, I don't know, I'm not a huge fan of the wick. Especially for that last cleaning step there. Another thing with the wick that's a lightly, yeah, I'm just moving the problem around. All right. Another thing with the wick that's slightly dangerous is if you take away your iron first and then the wick cools down and you try to pull away the wick, you can actually lift traces right off the board, which is really not great at all. It's called a pad lift or a trace lift, and then it's a really completely different problem. Let me just put a few more tunes on. All right. There we go. All right, I'm going to, as I said earlier, I'm going to slowly put this back down. And then manipulate it a bit more just to get a better feel for it and how it moves, and see if there's a better way to support this. All right. Okay. This actually feels like reasonably solid. Looks like a small guy. Hello, my name is Mr. Keyboard. Little feet and some fat arms. So let me try something here really quickly. What if I actually hold it like this and just gently rest these things? Okay. Like this. All right, I think this is my ticket. I'm resting the key wells onto these bottom parts here. I said I'm resting the key wells. All right, and then I just have to find a way to hold this up. I don't think my universal vise is gonna cut it, but maybe my third hand again. Okay. Okay. All right, here goes nothing. I mean, it's not like I'm, you know, whipping it around either, but I don't think this is really made to be. Yeah, this is not gonna work. Okay, abort, abort, abort. Okay. Okay, what if I feel a success coming on? What if I use the vise to hold the third hand, thus giving it a height boost? Oh, I like where this is going. Oh, yes. All right. I feel like this is a winning solution. Is this even gonna fit in there? I'm not even sure it's gonna fit in there. I think I'll run out of room. Yeah, no, doesn't fit. All right, it's a couple millimeters off. Okay, I have another solution for this problem. Let's put this back in. Time to get serious. All right, this guy's not gonna move. All right. Okay. This is so janky. Okay, got one of them down. And then the other one down. And then here we have it. These are sort of supported. Except, I hope you'll pardon me, but I think I made another mistake here because I want to have access from this side. You know what? Maybe I don't need to. Maybe I can actually clean it up from this side. All right, let's do that. Uh-oh. Just didn't mean to do that. All right. Oh man, this moving all over the place. Nice and clean. All right, tell me about it. Oh, these are really, this is really coming nice. Okay. So I'm trying to see where there's still crap there. All right. And one last hole. See, when you have access to the other side, this is so much easier. Okay. Okay. Let's try these holes. Ooh, very clean. Clean, clean. Oh, this is nice. It's like flossing the board. Oh, very nice. Feels very clean. Okay, awesome. Now I think we can truly say 1 down, 1 to go. Truly. Now the thing is for the other connector, man, I had to exert so much force on the board that I think I'm better to go back to my original situation there, where I had it on the edge of the desk. Yes, indeed, 1 down, 1 to go. So instead of just wasting you guys' time with this, it's going to be the exact same job. I think what I'm going to do is I'm going to move away from the soldering from now, and I'm going to go back to the print for a second because the printer job's finished, and so I'm curious to see what the PCB looked like and what how the key wells turned out and everything. So that should be a nice. What time is it? 10:45. Yeah, maybe a nice conclusion-ish to this stream. So let me get this back on the desk. At least we know there's a way to do this. All right. Not breaking anything. Turn off the iron. All right, let's get this out of the way. All the stuff here. All right. That thing is heavy. Okay. Let me take the print off the printer. All right, this didn't turn out half bad. Let me focus on this to go for you. A bit of stringing there. Yeah, that's not too bad. This is easily cleaned up. See the elephant's foot here along the edge. It's a bit too squished. Yeah, see, you can barely see the grooves on the inner side. Ah, this is unfortunate. It was way too squished. See, I kind of surmised this when I saw the first layer going down. Okay. Okay, well, so this PCB didn't turn out. But the principle is good, and I'm confident with the principle. Let me try to push a switch through here, see what's what. You've got the soldering iron right in your, there we go. So if I try to put the switch through this hole, yeah, it's a bit tight actually for the same, well, it makes it in, but you know, for the same reason the traces are kind of super tight, these holes here for the switches to poke through are super tight as well. So it does make it through, and you can actually see that the Just quickly grab focus here. So there we go. You can actually see that the metal still pokes out, which is good. Means we've got enough room to solder on this. Means the groove can be that deep and it should still work. There we go. You can see the printer had the right idea there, make it all the patterns and stuff for the grooves, but it just squished the first layer down too much. But I'll have to make a few tests. You know, if I can dial in the first layer just right, maybe this will work, and it'll be easier to print it as one part. Maybe I'll print it as two parts in the end, who knows. But next thing I wanted to try, just really quickly, was to actually fit this piece inside the keyboard, and maybe with some keycaps on. So there we go, one switch, there's a second switch here somewhere I can grab, some keycaps. There we go. Grab a switch. Oh, I'll grab the switch here actually. Bit of a tight squeeze. All right, and then lastly, steal this switch. Like that. All right, fitting all this, so I've got all the three switches in here, like that. And put some keycaps on this. Nice, I've got a three key thing going on there. Will you focus, please? Thank you. There we go. And then let's see what this looks like in the keyboard case, which is now quite empty. Wait, what's going on here? This doesn't fit nearly as well as the old ones did. Okay. Oh, there we go. Properly registered and everything. Oh, this is nice. So I still need to adjust like a couple dimensions here and there, I think, because see how again there's a bit too much of a gap on this side and not enough on the other side. This needs to be exactly centered for it to work properly. And I mean, I can wiggle it, like, you know, I can kind of move around a little, which is not great. This obviously, if you have the full 12 key set, or 9 key set rather, it's not going to do this. But I'd rather it didn't to begin with. In fact, something really fishy is going on here. Oh, okay. Okay, yeah, I still got a couple fit problems here. Okay, so my problem is, or one of the problems is these tabs here, this tab, and the tab down here, they're getting in the way. They're running interference. Now, initially, I had problems with the ribs that are up here as well. I got rid of that using the chamfer. Or I thought I'd gotten rid of it using the chamfer. I might have to make the chamfer bigger. I might also have to make a chamfer on this side of the piece to make sure that it fits in everywhere. Anyways, these are minor details. I mean, these are things, you know, 5-minute changes that I can change and print. You know, nothing major, certainly nothing process related. So I mean, I'm super happy with the way this is going. I think the PCB is going in the right direction. I really like these large pads. I like that we've found a process to be able to desolder these connectors. Now that I look at it, I don't think it's a burn mark. I really just think it's dirty crap flux, probably from either the original solder or this, maybe my tip was a little dirty. I'm not sure. I'll find a way to clean that. I've got a couple chemical products there that would help with that. And here I think I'll probably iterate a little bit on the fit, but in terms at least of the separation on this axis of the keys, it looks perfect. Everything looks perfectly centered, so that's good to know. And I think that's it. You know, I think for tonight that's a nice place to stop. I thank you all very much for joining in. Thanks everybody for the suggestions and the questions. The questions were super pertinent. I probably am going to look again into that desoldering gun. It's really this experience has made it painfully evident to me that would be a useful tool to have. Yeah, so hopefully next time, you know, I'll have the connector desoldered properly. I'll have at least an idea of where to go with the PCB in terms of how to print it, and maybe we can start assembling stuff and actually getting keys in this keyboard and testing some electricals and stuff to make sure that the circuit is functional. So yeah, thanks again, and I will see you soon. Have a good one.